Hi YouTube, Hawaiian Shirt Coder here again. We're continuing our series with our Web API. This time we're going to see how we can improve our Web API to make it more production ready. So if you've been watching our videos in sequence, you will have completed video 2 or part 2 and video 3 or part 3, and those give you the bare basics for creating a web API from start to finish. So after completing both those videos, you have a basic understanding of what's involved with creating a web API. You've got all the features you need. You've got the ability to get data from the system. You've got the ability to post new data to the system. You've got the ability to update existing data that's in the system. And finally, you've got the ability to delete data from the system. So we've made use of all the HTTP verbs that we need for a basic CRUD web API. So your system at this stage, if you went no further, looks like we've got on the screen. We've been concentrating on the player controller, but it's much the same for the fixtures side of the sports management system. So we've got our sports management web API, and we have, for the example I'm showing here, some external application that wants to make use of this public web API, and that's called our client application. Our client application can make requests using our RESTful Web API, the gets, the posts, the puts, the deletes, etc. And for this cut down version, it can make requests for everything to do with a player. On making those requests, we hit various endpoints or methods within our player controller that may be for getting a player, adding in a new player, or deleting a player. All of those involve us working with a representation of the data that is our player model. And that player model maps almost with a one-to-one relationship between the fields in our database. At this stage, at the time of writing our database, to be fair, is purely an in-memory list of players, but that's irrelevant for this particular diagram. So that's what we've got in place at the moment, and what we're going to talk about in this video is trying to improve that. So at the moment, our application we've created is demoware, purely for showing how the various HTTP verbs make up our web API. Now we're moving into the realms of trying to improve our web API so that it is more production ready and is no longer demoware. So in this example, I'm going to point out one particular improvement or flaw in our existing design. I've highlighted it here with the red circle. So imagine that a user is using our add player endpoint from their application. They've got some sort of UI on the screen that lets the user of the system add players into the underlying system, and at the moment there isn't anything to sort of validate the data that's coming into the system. So the client can submit rubbish to the player controller, which will pass it onto the model, and it will end up in our database. It may not be valid at all. One example of this is one of the fields in our player controller that is an email address. At the moment, the email address is stored as a string in the player model, and in turn as a string in the in-memory database. So as long as the client supplies a string for that field, the information for that email address property will get posted, even if it isn't actually an email. And there lies our first improvement validating the data the user supplies to our web API. So based on video 2 and video 3, where we get API data and modify API data, we've basically got the end-to-end web API in place. However, we've got several other videos in the series, this being one of them, where we can finesse our solution to use best practice and more infrastructure like databases and things like that. So here is our API as it stands at the moment. At the time of recording, I am still using the in-memory database, but that's irrelevant for this video. I was looking through our API and I was looking at the post method. The post method lets a consumer of the API add in a new player into our sports management system. And if you look at the moment and try it out, it will submit a new one into the database. But I thought, oh, let's just have a play with some of the values. So if I just say take out the first name, the last name, the email address, the phone number, and I execute, I get a 201 that it is completed and added it to the database. We go and have a look at the get all players, try that out, execute. There's our new player. However, we've managed just through that little demonstration to post rubbish into the database. So we've got a first name of nothing and a last name of nothing, which has given us on this particular call a full name of nothing. So this is what's known as allowing the user to post rubbish into the system, and then the user at a later date will get rubbish back out, as there's no validations in place to sanitize the data entry that is got supplied by the user. So this is a problem with our good citizens hat on we need to address. So let's just shut down Swagger and have a look at how we do this. So I've currently got open the model for a player where we've got the ID, first name, last name, email, phone number, and if they're active or not. And at the moment, a lot of these fields are strings, and if it's a string, you can leave it blank or you can supply anything. So we need to add some rules to our data to make it more meaningful. So the first rule is we need to look through our list of properties and say to ourselves which fields must we get some sort of data from the user. And I would say as a starting point we would need that the user definitely supplies us with a first name, and in order to do that we need to use something known as data annotations or attributes. So to do that we go squared bracket required, and that's it. Now you get a red squiggle because it doesn't know what that is at this stage. So if you do control dot, it will come up with suggestions, and the top suggestion is the one we need, using system.componentModel.data annotations. So if we click on that one, that will bring in the using statement at the top of the screen, and let's just see what effect that has on the first name property when we try to post in a new player. So we'll spin up the Swagger documentation again. Here we go, and we'll open up the post and we'll try it out, and we'll leave the first name blank and we'll just execute, and we get a 400 error back rather than a 200 or 201. And 400 error in HTTP status codes means bad request. A bad request means you've supplied something to the back-end server that is not correct, and it actually tells you what you've done wrong, and it tells you that the first name is a required field and you supplied blank, so it's failed validation. But more impressively, what it's done, if we go close this one up and go to the get player and try out, we'll notice that that new record that we tried to add has not been added to the database, as it's broken data validation rules. So this is good. Let's close this and see what else we can do. So based on that, I would say the last name also needs to be required, so I'm going to stick the required attribute under that. I'm also going to stick it under the email address. You must supply an email address when adding a new player. We'll leave the phone number as optional, so it won't have a required attribute on it, and you must always specify if this player is currently active player or an inactive player. So that's good. So all of a sudden all of those should validate. We can try that in a minute, but let's see what other things we can do. So if you look at the properties, you'll notice that most of them are string fields. Now a string will let you submit anything, including a blank, unless you've put required on it. So let's just have a play with email address. So if we fire up Swagger again, and go to the post, try it out, and we'll leave all the fields as it is. So email address at the moment, the email address is just called string, and if we execute, we'll get a 201 back, and that's been posted into our database. There we go. However, by submitting an email address with just some random string that isn't actually an email address, it's not very useful and may cause problems in our system further down the line. So again, this is a case of bad data, so we need to validate for the email address actually containing something that is recognized as an email. So let's go back to the system. Now how we can do this with data annotations is there is a built-in email validator for us. So if we just go square bracket email address, what this is behind the scenes is a regular expression that says for a given string we are expecting an email address, and an email address is of this pattern. So let's just try this just to show you how it works and the effect of adding this attribute has had on our payload. If we open up the post again, go try out. Now the first thing you'll notice is the documentation has been quite intelligent, and it has picked up that we've put an attribute. So it's given us a sort of sample of the expected data that's required. User at example.com. So if we just change this so it's not a valid email format like this, submit the data, we get a 400 error back and we get a validation message. The email field is not in a valid email address. So that's good. So what we can do now is put this back again. So that is correct data for a potential email address. If we execute this time, we get a 201 and the data has been submitted to the database. So that's good. There's several other ones. So you could do there's one also for a phone number, which again is a regular expression. Just fire that up just to see what that looks like. and hopefully again it will give you a clue to what the format of a phone number should look like. It doesn't in this instance, not to worry. Let's take that one off for the time being, as it's not a required field anyway. So some of the other things you can do with strings, like I said, because they can be anything, is we need possibly to be able to restrict how many characters can be entered for a first name. So we can do that with this attribute, max length. So we'll say for a first name, the first name can be no longer than 10 characters long. Let's just try that one out. So again, if we try out, and we're just going to change the first name to have more than 10 characters, submit, we get a 400 error, and you can see that validation is kicked in. The field first name must be a string or array type with a maximum length of 10. So that's good. One thing we can do is, if we don't like the error messages, we can customize them. So we can do that by adding this in, error message. There we go. So if we run that one up again, try out first name, lots of characters, execute, and now we've got our custom error message. So the other thing to note is all these can work in conjunction at the same time. So we could submit lots of bad data. So for example, we've got too long a first name, we've not supplied any last name at all, and our email address is invalid. When we hit execute, we'll get a list of error messages that have come back that are validating the data. The email field is not a valid email address. The last name is required, only 10 characters for the first name. So that's probably all I want to say about validations, but they are important, and as good citizens we should do them, because you can't trust user input. And if you don't validate the data, you end up with a scenario of rubbish in, rubbish out. This has only just been a taster into possible validations that you can do, but I will include a link to this article on the learn.microsoft.com website that goes on about things to do with data annotations and validations in a lot more detail. It's also referred to sometimes as model binding. And as you can see, we've gone through a few of these today. We've gone through some out of the box regular expressions, so you can create your own custom ones, the required field, things to do with string lengths, and like I said, you can create a validation from scratch yourself. There's a nice example of validations there. There's an example of a regular expression. Regular expressions is a dark art all in its own right, and is probably the subject of its own series of videos. The only other thing to say is this model bindings is something that applies to both MVC websites and our ASP.NET web APIs. So we've overcome our problem of supplying rubbish in. and getting rubbish out through data validations. There's other ways of doing it as well, through fluent validations and whatnot, but I'll leave that as homework for yourselves to look up. So the learning outcomes have been to validate our data as it comes into our API. We've done it through data validations. Like I said during the video, here is a resource to get more details as we've only just touched the surface. So I'm the Hawaiian shirt coder. That's the end of this session. Please remember to like, subscribe, share with your friends. Remember, keep learning, keep exploring, keep developing, and I'll see you next time.